I want you to pause the video and solve this homogeneous differential equation. Okay, finished? Let's look at it. So here, you cannot solve it by direct integration, and you cannot solve it by separating the variables. So what we're going to do here is let y be equal to vx. Therefore, dy by dx is equal to, you use the product rule, v and x are functions. So you hold v, differentiate x with respect to x, which is 1, and multiply them, plus you hold x times differentiate v with respect to x. Alright, that's x dv by dx. Now let's transpose for this dy by dx. Let's see, dy by dx is equal to, you subtract xy plus y squared, and you divide by x squared minus xy. But hold on, let's see something. First, remember, y is vx, so change the y's to vx. But before you do that, equate them. Let's write this one on the left and this one on the right, because you see dy by dx is same as dy by dx. And then we change the y back to we change the y to vx. So v plus x dv by dx is equal to negative x. Now, this is vx plus v squared x squared over x squared minus x vx. Now that gives us negative, say, vx squared minus v squared x squared over x squared minus vx squared. Okay. Plus. Why did I write minus here? Plus v squared x squared. Alright. So v plus x dv by dx is equal to, look at this. You could put the x squared outside the bracket here, no? Alright, v plus v squared. And down the bottom too, you could do the same, x squared outside the bracket and have 1 minus v. Alright, x squared cancel x squared. So you have negative v plus v squared over 1 minus v. So v plus x dv by dx equals, what happened here now? You could put negative, if you open the bracket, that's negative v minus v squared over 1 minus v. Alright, instead of starting with a negative v up top, how about multiplying both numerator and denominator by negative 1 and putting the v squared part first? This would be a positive v squared plus v, right, over this negative v would become positive and this 1 would become negative. Alright, so that's what we have here. Now, let's see what will happen here. We can multiply, no, let's subtract v. So you have x dv by dx equal v squared plus v over v minus 1 minus v over 1. Let's do some fractions. V minus 1. V minus 1 into v minus 1 goes 1 time. 1 time v squared plus v is just v squared plus v minus 1 into v minus 1 goes v minus 1 time. The v minus 1 times v is a v minus 1. Okay. So x dv by dx equals, what happened here now? V squared plus V, negative V times V would be negative V squared. Negative V times negative 1 would be positive V over V minus 1. But the negative V squared minus V squared, that's gone. V plus V is 2V. 2V over V minus 1. Alright? So, here, we want a function of V dV on the left equals a function of V of x dx on the right. Let's multiply by V minus 1 and divide by 2V dV equal, let's multiply both sides by dx and divide by x. So that's what we have. Okay. Oh, by the way, this, you see, can be written as V over 2V minus 1 over 2V dV. All of this dV equal 1 over x dx. But V cancel V. So this becomes half. So 1 over 2 minus 1 over 2V here. Okay. Which is half times 1 over V. Let's separate them. And what we could do, put half outside the bracket. So we have half times 1 minus 1 over V dV equal 1 over x dx. Alright, good. Then we integrate both sides. We can put the half outside the integral sign. Integrate. So when I integrate this, let me write the half from now before I forget it. Integral of 1 with respect to V is just V minus integral of 1 over V dV is ln V. Alright, equals ln x plus c. Okay. Now, what happens here? What can we do? The fact that y equal vx means that v is the y over x. We can say half y over x minus ln y over x. Right? Alright, let's keep it as that. Equal ln x plus c. Alright, that's our solution. We could neat it up a bit. We run out of space when it comes to scrolling down, so let's draw a line here to separate the work and continue working over here. Alright, so what do we have here? Let me just copy this thing and combine this one and work with it up here. By the way, let's get this out of the way. Alright, so this is what we have here. So, what can we do with this now? Could multiply everything by 2. We'll say y over x minus ln of y over x equal 2 ln x plus 2c. Or 2c is just another number. Let's call it a, no? A. Alright, so what else can we do with this? We have ln y over x. Suppose, well, can we put the ln's together? Suppose you have y over x minus a, you subtract a from both sides, equal to 2 ln x is the same as ln x squared. Alright, plus ln y over x. Remember ln, what ln something plus ln something else is like, if you remember your laws of logarithms, when you have ln of a number plus ln of another number, for example, say 5 by 6. Alright, ln 5 plus ln 6 is equal to that 3.4 something. Now 5 by 6 is 30, so if you have ln 30, you get the same thing, right? 3.4 something. Any two numbers you try, it will work. So let's say this is, let me see now, y over x minus a is equal to ln x squared y over x. Okay, it's x squared y over x, which is the same as ln xy. Call it ln xy now. Alright, so ln xy, what's a neat way we could put this now? If we multiply by x, we would have y minus ax equal x ln xy. Alright, so y, alright, this is what I have so far. So it's just a matter of neating it up a bit. Come to think of it, we could do this too, you know. Suppose we have, let me see now, ln xy is equal to, this is y over x minus a. If we have the LCM x into x goes one time, 1 times y gives you y minus over 1 into x goes x time ax. Suppose we do this, and then we say e to the ln xy equals e to the y minus ax over x. What would happen? This would be xy equal e to the y minus ax over x. Alright, I guess that's one way that we could put it. Alright, it's one way to put it. Come to think of it too, you know, from our knowledge of the laws of indices, you could write this as xy equal e to the y over e to the ax. Let me see. Oh, guess what? Let us keep it as y over x minus a. That's what we could. Come on, that's one thing we could do. Let's keep it at that and see what would happen. We could have it here as ln xy equal y over x minus a. Now, y over x minus a. Negative a is a constant. Instead of using negative, let's call it plus b. Alright, negative a is the same as positive b, because we don't know what a and b are. It can be anything, so we can play around with it and change it like that as much as we want. E to the y over x plus b. Now, suppose you do this, it means e to the y over x, e to the b. But e to the b is yet another constant. Call it d. So xy equals d e to the y over x. Right. We could do that, man. Alright. So can have that as our solution. So I will see you in the next video.